we are discussing now about installation and heat budget. Now, what is the factor that temperature of planet determines? Say for example, if I am talking of Mercury, then Mercury is supposed to be first planet from Sun, but Mercury, as it is very close to Sun, it should have maximum temperature, surface temperature. Second planet is Venus, third is Earth. So comparatively less temperature is observed on Earth. But in case of Venus, we are getting higher temperature than that of Mercury. Reason lies in the atmosphere. In case of Mercury, the atmosphere is not that dense, very rare, almost 10 to 0 atmosphere is present. As a result, the side which faces towards Sun, that of Mercury, is having very high temperature, but side which is at dark, that is opposite side of Sun, that is having temperature less than 0 degrees Celsius very easily. This is the reason we are having different conditions, that only distance from Sun is not important characteristic. Apart from that, the atmosphere, then presence of lava or that whatever the underground liquid is present, that is also important. Say for example, some of the satellites of Saturn, they are having very high temperature, unexpectedly high temperature, because if you are there at Mars, then temperature is considerably low than temperature of Earth. But on that certain satellites of Saturn, temperature is high. That is because of lava present. In case of Earth also, if you observe Iceland, then in Iceland, certain places are there where high temperature is observed. So it is not necessary that the entire land is covered by ice. Even on Antarctica also, as Antarctica continent is the most cold continent, but still it is expected that there should not be water present, that in liquid state on Antarctica. But there are certain lakes, I don't know, but I have observed certain videos that they are showing that there are lakes on Antarctica which are having water. That means instead of ice, it is in form of water. Now here also the temperature of planet is determined by number one, how far it is from Sun. What are the other forces also, gravitational forces? Say for example, in case of satellite of Saturn, this is because of very high gravitational force given by Saturn that will cause the volcanic activities, and therefore temperature of planet is high, temperature of satellite is high. So like that forces also we have to consider. Then what is the, particularly we are saying that density of atmosphere. Say for example, in case of Venus, the density of atmosphere is very high, and therefore the energy, that heat is trapped, and therefore temperature of Venus is very high as 400 degrees Celsius. So it is very high temperature there. Now in case of Earth, we have to determine that basically Earth's temperature, that is surface temperature on Earth, that is because of Sun. Internal forces we are not considering here. Internal temperature, say for example, lava is very hot. One may say this way also, that inside that earth crust there is lava, liquid state, and that heat is transferred to surface. May be possible, but that is negligible, because basically we are considering that earth's crust is considerably poor conductor of heat, and therefore only supernant part is heated by atmosphere, by sun's radiation or solar radiation. Now here we have to consider that sun is giving entire radiation or heat whatever there is on surface of earth. Now as we discussed earlier way, in previous lectures also we discussed, again I have to tell the same thing, that try to recollect our spectra from gamma radiation to violet radiation, to red radiation. So gamma, that is invisible, to violet, that is invisible, but violet to red visible. These all radiations are called as short radiation, short wave radiation. Infrared onwards, that means if we have to include infrared and onwards, the radiations are called as long radiations. Now, Earth's atmosphere is passing out certain visible radiations, whereas they are absorbed to very less extent, but infrared radiation onwards radiations are absorbed by Earth's atmosphere. They are called as short radiations. To greater extent they are able to absorb. Now, sun is radiating energy throughout its surface area. So suppose I am saying this is the sun. This is considerable, we have to consider this is spherical in size. It is radiating in all possible direction, the heat or that radiations. Sun is emitting out gamma rays, yes, little bit. X-rays, yes. Vacuum ultraviolet, visible, infrared, all these type of radiations are emitted by sun. You are aware that these radiations are carrying out energy. Now, out of that, just check out. I am showing this way. Suppose this point is there. From this point, radiations are emitted in all directions, all possible directions. Out of that, suppose this is the zone where we are receiving this. This is Earth. As we are aware, this is dark part of Earth, this is lighted part of Earth. Now, Earth is receiving only from certain point energy. All other directions, say these directions, Earth is not receiving energy. So, suppose sun is giving us energy that is equal to 1. Then whatever Earth is receiving energy, that energy is 1 upon 2000 millionth part. That means I have to say this is 1 upon 2 into 10 raised to 9, or in simple way I can say it is 0.5 into 10 to the power of minus 9 energy given by sun. So simply 0.5 into 10 raised to 9 energy is received on Earth's surface. So suppose sun is giving 1, then we are getting this is the this is the amount of energy given by sun that is on Earth's surface. So we are getting very less energy given by sun. Now question is that how sun is getting this energy? We don't know. But what is that hypothesis? Or we are saying that there is a reaction that is called as nuclear fusion reaction that is going on sun. Simply we are not going in detail, but 4 hydrogen atoms, they are fusing out to get helium atoms. 1 helium atom plus whatever mass loss is there, that is converted into energy. This energy is tremendous high energy. This is even principle of hydrogen bomb. So very high energy is emitted by sun. That energy is radiated in throughout the direction. Now this is Earth. So Earth is receiving only 0.5 into 10 raised to 9 minus 9 part of energy radiated by sun. Now question is that this energy is entering in Earth's atmosphere. This energy, whatever the energy that is from sun that enters in Earth's atmosphere, that is called as insolation. I am revising the term insolation. So here the energy which is given by sun to Earth, whatever energy is received on Earth by sun, that is called as insolation. Now what are the factors affecting this insolation? Number 1, the sun's temperature is not constant. It changes, particularly if you are aware that there are some spots some dark spots are observed on sun's surface. Okay, let me clarify here that you should not observe sun with your normal eyes. Rising sun is all right, but rising means what? There should be sun on horizon. If it is coming out from certain mountain or hill, then don't try to observe. So if it is on horizon, then only you can observe. Otherwise, please keep in mind that certain ultraviolet radiations are there in sun's radiation. These ultraviolet radiation can impact our retina, that is the inner part of eye, and therefore permanent blindness will develop. It is a problem that vision is affected and it is irreparable. Say when we are saying there is eye donation, only cornea means upper transparent membrane of eye, that is donated, that is replaced, not retina, according to my knowledge. Anyway, so don't try to observe sun when it is at top, but with certain techniques we can take image of sun and we can observe. At that time certain dots, that means spots, are observed on sun's surface. Even there is cycle of 11 years of these dots, and then whatever the radiant energy given by sun, that varies. So you are aware now that with respect to that, insolation changes. Second thing, that is distance between sun and earth. You are aware that earth is revolving around sun in elliptical orbit and not circular one. Sometimes it goes close to sun and sometimes it is away from the sun. When it is going close to sun, we are calling this position as, try to recollect, perihelion position. Peri means in vicinity, helus means sun, so it is in vicinity of sun, so perihelion position. Whereas second, that is aphelion position, that means sun is away from earth, that is aphelion position. So both these positions affect the insolation. See, here I am placing perihelion position. So earth is close to sun, so we are getting more radiations here. As it is away from earth, it is getting less radiation. Say here is the place of Mars. This is Mars. So obviously Mars is getting less insolation. Whereas this is the position of Venus, Mercury. So Mercury is getting this more insolation here. So this way our distance from sun to earth is changing out, and that's why we are getting the change in energy. Now, when light is coming to earth's surface, insolation topic is now, let us take out. Now what happens after light is entering in earth's atmosphere? Say various radiations are absorbed by atmosphere. You are aware that gamma rays, they are having range of hardly 10 to 12 centimeter in our atmosphere. Our means lower part. In upper part it may have more range because the atmosphere is rare at upper parts. But still gamma radiations are absorbed. X radiations are absorbed. Vacuum ultraviolet radiations are absorbed. Ultraviolet radiations are absorbed to some extent, and part of ultraviolet radiation, keep in mind, not entire ultraviolet radiations are absorbed by ozone layer. Many students are having misconception that whatever incident radiations are there from sun, out of that whatever ultraviolet radiations are there, they are absorbed by ozone layer. No, only part of ultraviolet radiation, that part is actually harmful part, that is absorbed by sun, that is absorbed by ozone layer. Now here these radiations are traveling to earth's surface. Visible radiations are also only 14% absorbed. Remaining visible radiations are reaching on earth's surface. What happened exactly? That on reaching of earth's surface may absorb all radiation if surface is black, perfectly black, but it is not perfectly black, but maximum radiations are absorbed by black surface. So when we are saying there is regur soil, which is black in color, or a basalt rock which is also black in color, that will absorb major part of radiation, that is visible radiation. But if surface is white, then white surface reflects all radiations, and therefore we are getting comparatively less heating if surface is white. This is the case particularly in Antarctica, where already it is chilled one, which is having all ice covered land. For the years, ice is accumulating over the surface of Antarctica. No doubt what we are calling global warming, that is different, but here the problem of Antarctica is that ice is not melting out, because temperature will never go above zero, particularly inside the continent, and therefore there is accumulation of ice over the years on surface. No doubt glaciers are there, but still there is problem of accumulation of ice over there. Surface is white, so already very less heat. Surface is white, so whatever incident radiations are there, they are reflected back, and therefore heating effect is very, very less. So we have to consider all these factors. Suppose we are considering in case of plateau of Deccan, then in case of plateau of Deccan, majority part is covered by regur soil. If laterite soil is there, then it is all right. The color is not exactly black, but regur soil, the color is black. Again, what is the problem of Deccan Plateau? The Deccan Plateau is having basalt rock, and so if at all stones are there, they are also having black color, and so radiations are absorbed and converted into heat. So this way heating effect is there. Now in case of atmosphere, particularly the light is traveling. Just imagine these two circles are there. This is Earth, whereas this is its atmosphere around Earth's solid surface. The incident radiations are there from sun in this direction. Actually, we have discussed this topic in earlier lecture also. Here sun rays are perpendicular, whereas suppose I am talking of this portion. Say I am trying to keep this distance same. You will get here the angle is not acute angle, not 90 degree. Perpendicular angle is not there. Here I should say the angle is acute angle, whereas here it's almost 90 degree in this zone. Here see the surface under this radiation zone is very, very less, whereas here the surface area is more. So this much light is distributed over this surface. So intensity is less. As intensity is less, temperature is also less. Whereas in case of here, the intensity is more, and therefore perpendicular sun rays are carrying out more amount of heat. So whatever the temperature on Earth's surface is not constant. Many students are asking us this type of doubt. What is temperature of Venus? What is temperature of Mercury? Please keep in mind that what is temperature of Mercury is something problem. Suppose I am asking you, what is the temperature of Earth? What is temperature on Earth's surface? Answers are so many answers. I can give this way, that which is the surface. Suppose I am talking of Libya. You are aware Libya is in Africa continent around Mediterranean Sea. Just besides the Egypt, this nation is there. In Sahara Desert. Then temperature will be very, very high? No. During daytime in summer, temperature will be very, very high. But during night time, it is not necessary that temperature will be high. Suppose you are away from seashore, then during night time, even temperature can fall to 0 degree Celsius also, in desert particularly. So desert temperature range is very, very high. Range means what? Difference between maximum temperature and minimum temperature. If I am talking of Antarctica, then temperature is obviously very, very low. So can I say that temperature of Earth is minus 89 degrees Celsius? It's obviously no. Can I say temperature of Earth is a 55 degrees Celsius? It's also obviously no. And so the temperature on Earth is not throughout constant. It varies. with respect to its position. Suppose it is there on equator, temperature may be high. Away from equator, temperature will be low. If it is in vicinity of ocean or sea, then temperature will be different. And inside the continent, that means away from sea, temperature will be different. Anyway, so like that, various factors are there. Now we are focusing on another topic, that is called as heat budget. After this insolation, we have to start heat budget. So let us start out heat budget now.